Hi everyone, welcome to this video where we will talk about a few best practices of various AWS core services. So the agenda for today's video looks like this. We'll talk about the best practices for Amazon EC2, Amazon RDS, Amazon S3, Amazon VPC and AWS IAM. And before we begin with today's video, let me give a quick introduction about myself. I'm Aishwarya Sood, working as a lead coach in the AWS domain at Ethnus, and I am 4x AWS certified and Amazon authorized instructor, AWS Academy accredited educator. So if you want to connect with me on LinkedIn, here's my profile name, and also the QR code is given if you want to scan it and directly view my profile. So let's begin with the first topic for today's video. As we get started with the AWS cloud, it's very important to know about all the core services of AWS. They form the foundation of the architectures on AWS that we create. Such services may include Amazon EC2, Amazon RDS, AWS IAM, Amazon S3, and Amazon VPC, and many more. But these are the core services because they come under various categories. We build the compute, storage, database, security, and the networking for our architecture. They are the foundations, or you can say foundational building blocks for any architecture on AWS. Now it's even more important to know the best practices of working with these services. This will make sure you are using these services in the bestest way possible, which will eventually enable the efficient usage of the resources and huge cost savings, because there are many small things and details while using these services, and in which if even we make a little mistake, it can lead towards inefficient usage or increased overall cost of our AWS resources, and we don't want that. That's why knowing the best practices is important. So today in this video, we will discuss the various best practices and we'll see how to implement some of them on the AWS console. As a prerequisite, I'm presuming that you are aware of how these services work, and since we are not going to dive deep into these services, but we will just discuss the best practices of working with them. And if you are not familiar with these services, then before this video you can watch the separate videos for these services, like the one for EC2, the one for S3, and so on. They are also available on the same channel for a deep dive. So let's begin by discussing the best practices for Amazon EC2. This is the most basic and important service. First of all, you have to understand the implications of the root device type for the data persistence, backup, and recovery. So we have two options for it: instance store, the ephemeral storage or the temporary storage, and the EBS volumes, which are the persistent storage. Let's have a look at a few differences between the AMIs backed by both of them. Let me show you this differences. Have a look. If you take an EC2 instance which is backed by Amazon EBS, what will be the difference of it if you take a EC2 instance that is backed by Amazon Instance Store? There will be multiple differences. The main difference will be if you are taking the one with the Amazon EBS, it will provide you persistent storage, but with the Instance Store, it's just a temporary storage. So another things, you can see the boot time will be different, and the size limit also. You can have here 64 TB, whereas in the Instance Store it's just 10 GB as a max. And the data persistence, as I told you, it's there in the EBS, but the data in the Instance Store persists only as long as the EC2 is active. Once it is gone, the data in the Instance Store is also gone. Why does this happen? So is because this instance store resides on the same physical hardware as the EC2 instance is residing. So once you stop the EC2 instance and start it again, as you know that it will change its underlying hardware. It will not start on the hardware which it was present previously. That's why the data is left over there only, and it is deleted that was there in the instance store, because now EC2 is on the new hardware. That's why. Now few differences between the charges and this one, the EC2, if it is backed by EBS, it can be in a stop state and we can even change the instance type. But here the EC2 that is backed by instance store, it cannot be in the stop state. It can be either running or terminated. Why? Because since we are taking a EC2 whose root volume is an instance store, and if we stop it, the data in the instance store gets deleted. And that doesn't make any sense that the OS data of an EC2 instance is getting deleted in which the operating system was present. That doesn't make any sense, right? So it is not possible to stop this kind of EC2, and we can just keep it running, or we can terminate it if we do not want it. But anyway, EBS instances can be stopped any time without any issues, because EBS persists independently from the life of EC2 instance. So let's go back to our slides and discuss more best practices. Another point to notice here when we are talking about the volumes is use separate EBS volumes for the operating system and for your data. Ensure that the volume that is containing your data, this is also persisting even after your EC2 instance is terminated. Okay, you should not be doing like if you are deleting your EC2 and along with that you are also letting your volume getting deleted which was containing your data. So it's a good practice to keep that because it may be of your use. And then use data lifecycle manager that is available with the EBS to automate the creation, retention and deletion of the snapshots taken to back up your EBS volumes, and for an even better security, encrypt the EBS volumes and the snapshots. Let me show you where you can access it. When you go to your AWS console and you reach to your EBS volumes, here itself on the left navigation pane where you have all these things, you can see this lifecycle manager thing. So you can create a policy in this depending on like how you want to take the snapshots, how long they should be retained, and multiple things you can specify here, and it will be automating the process of your snapshots for the EBS. So this is a very good practice to take care of. And another thing, encryption. When you create a volume, while creating your EC2 or even after that, if you are creating a volume, make sure you encrypt this volume. This is for additional security, right? So you can encrypt this volume, you can define a key which is a custom KMS key, or you can take up the default key also which is AWS/EBS. Okay, so depending on your requirements, you can choose the relevant key for encryption, and then you can go ahead and create your volume, and make sure the key that you are choosing, you have the permissions for using that key. Otherwise there will be some issues while launching the EC2 or using this volume with your EC2 instance. That's why you take care of those permissions. So the next best practice that I would like to explain here is the AMI creation from a running instance. So as a backup option, when you have a running EC2 instance, let's go to our instances list. To keep it saved, you can keep an AMI of it. Very easily you can create it. All you have to do is go to actions, click on images and templates, and click on create image, and then you specify your details here, like the name of this image, and then if you want to add any additional volume with this EC2 instance, I mean the one that you are keeping it as AMI. So when you create a new instance from this AMI, it will have these relevant details which you are putting here. If you add one more volume, it will be available there. So you can define the things for here. If you want it to be deleted on termination, if you want the encryption, and so on, because this is the one that is additional and is unique to your AMI that you are creating now. But if you keep a AMI of your instances, it's a good option, so that in case something happens to my demo server, that is the current EC2 that I'm talking about, I will have the AMI available which I can use to recreate the same kind of EC2 instance till the time I had taken this AMI. I will have everything same to same in my AMI. So I will have it in the new instance as well. So it's a good option to keep an AMI at regular intervals from your EC2 instance. And then comes the next thing, monitoring. Monitor and response to your events. Anything that is happening on your EC2. So monitoring is an important part of maintaining the reliability, availability, and the performance of your EC2 instances and your multiple AWS solutions. You should collect monitoring data from all the paths in your AWS solution so that you can more easily debug a multi-point failure if one occurs. and you can monitor CPU utilization, network utilization, then disk performance, so that you can respond to the events accordingly. For example, if the CPU utilization of your EC2 is going very high, as a response to it, you may want to launch another EC2 instance to handle the load, in which the auto scaling can come into picture, right? And apart from it, least permissive rules for the security group you have to keep. Let's say your EC2 needs to allow the traffic from to allow the SSH traffic from your office IP address only. So what will you do? Will you allow all the traffic from all the IPs, or will you allow the SSH traffic only from your office IP? Of course, the second option. You will allow only the SSH traffic from your office IP as a best practice, so that only traffic that is supposed to come, only that will come to your EC2. Also, make sure to deploy the critical components of your application across multiple availability zones and replicate your data appropriately. Maybe you need some data in multiple AZs, or you want to keep it in multiple regions. Make sure you are aware of it and do the replication appropriately. Also, you may want to keep your instances in multiple availability zones and so on. So keep it that way, and always choose the right size, the right purchase option for your EC2. You must be aware of all the options available, like reserved instances and when to use spot instances, when to go for savings plans, and so on. So you should always choose the perfect pricing option so as to maximize the cost savings, and also the right size of the EC2. Maybe your workload is there which can fit very fine into T2.micro, but you are taking a T2.large. That is not a good practice. So you have to analyze like what amount of resources you are needing. Appropriately, you can take that. I know it's always not very easy to guess the accurate size that you will be looking for, but for that help you have other tools like Trusted Advisor and Compute Optimizer. Trusted Advisor can inspect your AWS environment and then make recommendations when the opportunities exist to save money, improve the system availability and performance, or help close the security gaps. And there is Compute Optimizer, which can tell you if you have underutilized EC2 instance, or if you, not the underutilized, but if you have a under provisioned EC2 or over provisioned EC2, or if you have a optimized EC2. Under provisioned in the sense your EC2 has more workload and the size is not enough that you have given. Then it will tell you you can take so and so EC2 in order to rectify this, and that will be the pricing once you take up my recommendation. If it says over provision, means you are running a very small workload but you have taken a very big EC2 instance, so it will give you recommendation that you can choose this EC2 and this will be your cost savings. This way Compute Optimizer can help you in finding the a very good option for your perfect EC2, the type and the size that you should go for a particular workload. Then comes the best practices for Amazon S3. So S3 comes under the storage category of AWS, and it's a very basic service when it comes into cheap storage. In our mind, we know that we have to go for Amazon S3. First of all, we have to ensure that our S3 buckets are not publicly exposed to the internet. For this, we can use S3 block public access, and with this, account administrators and the bucket owners can easily set up the centralized controls to limit the public access. Where do we find it? Like when we are creating, or even when we have created, let's say this is my S3 bucket, I'll go to the permissions. Okay, I can see here the block public access is available, and as of now it is public, right? Because I have turned it off. I have turned off the block all public access, but I have to be aware of that. Do I actually need it or not? Because if I'm keeping it off, it means anybody in the world with the URL of my object of this bucket, they can access, they can read the object. But if I block it and save it, it means I'm keeping it safe. Okay, I have to confirm it. So it means I'm keeping it safe. Not everybody will be able to access it, but only the controlled access that I defined through various policies, only that will be allowed, nothing else. And next, if you know the life cycle of your objects, like how long they are gonna be frequently accessed, how long they are gonna be infrequently accessed, or maybe how long they are needed, after which they can be expired, make sure to use the S3 lifecycle configurations. So it will automate the transition of your S3 objects from one class to another and can even expire the object at the specified time. So this will help you in saving the cost because it will be automatically moving the object from one class to another depending on what you have specified. Another thing that you have to take care is to ensure that S3 buckets do not allow unknown cross-account access via the bucket policies. If you do not need it, make sure it is not allowed. If you need it, of course, then you will go ahead for this. Only in those cases when you actually need it. And ensure that encryption at trust is enabled for your S3 buckets and their data. Again, where you can enable the encryption and the lifecycle policies, you go to management, you go here, lifecycle rules are available, you check properties, here you will get the encryption. Okay, as of now it is disabled, but you can click on edit for your existing bucket and then enable it, choose the appropriate key type, and then you save the changes, and your data will be encrypted at rest when it is stored in the Amazon S3. Okay, apart from that, you have versioning. So ensure that S3 object versioning is enabled when you want additional level of data protection. So here what happens is, even if you are keeping more than one version of the file, you can keep it. Like let's say we have a file with the same name and we have 3 versions of it. Okay, we want to store all of them in the S3. We can keep it if we enable versioning. Okay, the file with the same name but with different contents 3 times. Okay, so we can use a versioning for that, and MFA delete also. So when you do this along with the versioning, the bucket owner will include 2 forms of authentication in any request to delete a version or change the versioning state of the bucket. So basically this will add additional protection to your objects. Then look for the bucket policies that allow a wildcard identity such as principal with the star, which effectively means anyone. Star means all or anyone, or allows a wildcard action, which means all the actions. So if you don't need all the principals to be allowed or all the actions to be allowed, make sure to remove this wildcard entries and specify the particular action or the principles that you want to give. And when granting the permissions, you decide who is getting what permissions to which S3 resources. You should follow the principle of least privilege over there. Grant only the permissions that are actually required. Do not grant any unnecessary permissions. If somebody needs read access, give only read access. I know full access can also give the appropriate permissions, but it will be very broad. You don't have to do that. Okay, only give the permissions that are actually required. Also, you can use a trusted advisor to take help for this. It will inspect your S3 implementation and will let you know if you have given a very broad access or is it okay, and so on. So the next service that we have here is Amazon VPC, which comes under the networking category. And while working with the Amazon VPC, first of all, we have to very carefully think about its requirements. Okay, like do we want a VPC with a single public subnet, or we want a VPC with public and private subnets, and so on. So that we should create only the resources that are required and nothing unnecessary. And when you add the subnets to your VPC to host your application, create them in multiple availability zones. Okay, using multiple availability zone makes your production applications highly available, fault tolerant, and scalable, so that like even if one AZ goes off, you will have your resources in another AZ. How do you do that? Let's say we go to the VPC, we click on create VPC, and we have just already selected VPC and more. Okay, you can give your relevant details here, whatever you want, and number of AZs you specify here. Okay, do you want it in one AZ only? Do you want it in 2 AZs or 3 AZs? Okay, so the more AZs you use, the more availability you will have, and you can choose accordingly as per your requirements. Another thing, make sure you are using NACLs, which stand for Network Access Control List, and the security groups. So both of them are the firewalls. Security groups are the firewalls at the EC2 level, instance level, and the NACLs are the firewalls at the subnet level. So NACLs will decide what traffic can go inside and outside of my subnet. Security groups decide what traffic can come inside and go outside of my EC2 instance. So I should give the appropriate rules in them. As I told you previously also, I should not be giving any broad rules whichever are not required. Only give the specified rules that are like for the traffic that is actually supposed to come inside your network or the servers and so on. Okay, no need to give any extra rules. Then choose the appropriate CIDR blocks, which stand for classless interdomain routing. So this is basically the IP range that you will be giving. You should give appropriate CIDR block. Okay, it should not be very big, it should not be very small. Make sure there is some IP addresses left, so that in case in future you want to add more resources, you should be able to add within the subnet. You will only be able to do that if you have the IPs left. Okay, so if you consume all the IPs now only, there will be no way left for the scalability for adding more resources. You can change if you are using the IPv4 block. You can then change the IPv4 VPC size by adding or removing up to 4 secondary CIDRs. But if you are going for IPv6, then you can't change the size, not at all at there. So the maximum that you can give is /16 and the minimum you can give is /28. Okay, and for this IPv6 you have this /56 as a fixed. So where do you give the IP address range? Here, if you have seen IPv4 CIDR block, like if you are giving this one /16 with this range, it is showing that it will have 65,536 IPs. If I say I'm giving as /24, then I just have 256. So maybe this is enough for me. I'll go ahead with that. But if I think I need more IP addresses, I'll give as /20. So there should be not like very large set or not a very small. It should be just sufficient. So you can analyze your workload, think about it, and give an appropriate CIDR block after that. Another thing, it's best practice to isolate your environments across multiple VPCs for the deployment, QA, staging, and of course the production environment. It's not a good practice to keep everything in a single VPC unless and until you actually have a requirement for high performance computing, or you are just small team deploying a very small application. Otherwise, multi VPC is a good choice. And in case you want to connect 2 or more VPCs, then you can use VPC peering in that case. But make sure to peer only the VPCs that are actually requiring to communicate to each other. Do not peer any unnecessary VPCs. It will make a mess. And if you are planning anywhere for peering 2 VPCs, make sure you are giving different CIDR blocks to them, because if they have overlapping CIDR blocks, they won't be able to be peered. So you have to take care of that. Another thing that you have to take care is custom route tables. With the VPC, we get a main route table, and for different subnets, use different route tables. Use the custom route tables depending on what routing requirements they are having. Maybe a public subnet, because it wants to talk to the internet, it will have a IGW or the internet gateway entry. But this entry won't be there for a private subnet. So it is a good practice to use custom route tables for various subnets in your VPC. Next service that we have here is AWS IAM, or Identity and Access Management. When working with IAM, first of all, you have to make sure you are safeguarding your root user credentials. What does it mean? The root user is the one with which you create your AWS account. And for frequent activity, do not use the root user credentials. Instead, create an IAM user, give that IAM user the admin policy, and use that one, which will make sure your root user credentials are kept at a safe place and you are not using it for a frequent usage. And it is a good practice so that they can be protected from getting compromised. Okay, so you have to keep them safe. Another thing, you can enable MFA. So Whenever you are needing IAM or root users in your account, whatever it is, even if it is the root user or MFA, sorry, even if it is the root user or the IAM account, make sure you require MFA for them for additional security. So this will ask the users to enter an additional code over and above the usual credentials, which will enhance the security. So usually what you do is you give your username, password and the account ID if you are an IAM user, and you press enter and you will be signed into your account. But if you enable MFA, after your username and password, it will ask for a code also to be entered, which will be a kind of OTP thing. Okay, so you enter it, and this way your account will be even more protected, so that even if somebody gets your credentials, they won't be getting the MFA code, right? So it can be protected in that way. Another thing, least privilege principle, as I told you previously also, whenever you are applying the permissions for somebody, you are giving the policies, make sure to follow the principle of least privilege, which says you have to give only the permissions that are actually required. Think about, like, let's say a person is asking 10 rupees from you, and you can give him 50 rupees note, or you can give him straight 10 rupees note. Both the notes will serve the purpose, but 50 rupees is like you are giving him some extra, right? 10 rupees is like whatever he asked, you just give him that only. So as a best practice, you will give him 10 rupees only, nothing extra, right? Similarly, you have to follow in the permissions. If somebody is asking for read access, give only the read access. No need to give the full access. And then we have the IAM access analyzer, which analyzes the services and actions that your IAM roles use, and then generates a fine-grained policy that you can use according to the usage that it has analyzed from your IAM role. So after you test each generated policy which it has generated, you can deploy the policy to your production environment, and this ensures that you grant only the required permissions to your workloads. Where can you get it? You go to your account, you check this access reports. Under that you find the access analyzer. You first have to enable it. Okay, so let it open. So yeah, here first you have to create an analyzer. Then you will have this, just a second. Then you will have the active findings, what it has got, and then you can take the appropriate action by using the relevant policy. So there you can find the access analyzer. Another thing that you can take care of is you can use the groups. If you have multiple people who need the same permissions, add them to the group and add the permissions to the group instead of assigning the permissions to individuals. And you can use the conditions in the policy, which will help finer access control to the AWS resources. For example, access will be limited to specific IP range, or allowing only the encrypted request for uploads to the S3 buckets, or something like that, which will be like adding a particular condition in the access. Then you can use IAM rules when you are providing some temporary access, or maybe one AWS service wants to access another service. In that case, it's not a good idea to keep your credentials stored somewhere on the service. It's a good idea to assign the IAM rules for the access, the temporary access in that case. And then enable the strong password policy to define the passwords requirements, forcing the users to create passwords with requirements like at least one capital letter, one number, how frequently it should be rotated, and so on. So where you can do that when you are in IAM, you have to go to account settings from the left navigation pane, and you will have the strong password policy option, or you can change the password policy, and you can define multiple things whichever you are looking for. But make sure to keep a strong password policy, like it should include multiple things and how long, after how frequently it should be rotated. Okay, so that's how you can work the best with IAM. Next service that we have here is RDS, where first thing that we have to take care is look for appropriate RAM for your DB instance. This goes on for, like we had it discussed in the EC2 also, same goes for RDS. when we are creating a DB instance, we have to look for a particular DB instance type. So we should be aware of how much RAM we are needing for it. Okay, so that nothing is wasted and we are getting a appropriate size of the DB instance. Then you can use enhanced monitoring. With enhanced monitoring, RDS will provide metrics in the real time for the operating system that your DB instance runs on. And this way you can use those metrics to identify any sort of operating system issues. So if you need that, go ahead, use the enhanced monitoring. Also identify overutilized or the idle EC2 the RDS DB instances. Okay, you can once you identify the overutilized instances for the RDS DB instances, you can upgrade them in order to optimize the database workload and the response time, because they are like stuffed with the workload, so you can give a bigger one. And when you see an idle DB instance, you can terminate them to optimize the AWS cost, because why to keep any unnecessary resources. Another thing, you can make use of multi-easy deployments if you are looking for high availability with your RDS DB, and you can make use of read replicas when you have a read heavy workload, so that the load can be offloaded from the primary DB instance and the read queries can be served through the read replicas of your DB instance. So you can use that. All you have to do is have an active RDS DB instance, go to the actions, and you will have this option for creating read replica, and it will start creating that. And then make sure there are no unrestricted security groups for your DB instance, means it should be only allowing the traffic that is supposed to be allowed. Also, make sure that your DB instance is not enabled for public accessibility unless actually it is needed. Okay, so when creating your RDS DB instance, you see this option. Should it be publicly accessible? Should it be getting a public IP? Yes or no? So by default it will be no, but if you give yes, you should be mindfully selecting that only if you need it. And then you can enable automated backups with your RDS DB instance and set the backup window to occur during the daily low and write IOPS, not when it is being very highly used, only when it is like having low operations. In that you can specify the maintenance window. That is when the backup will be least disruptive to your database usage. And then you can use the RDS DB event to monitor the failovers. For example, you can be notified by text message or email when your DB instance fails over. Okay, so these things you can take care for when you are working with the Amazon RDS. And last but not the least, you can always refer to the well-architected framework of AWS. It composes 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Basically, it helps you to create the architectures on AWS by guiding you how to follow the best practices under the very important areas which are its design pillars. And it describes the key concepts, design principles, architectural best practices for designing and running the workloads in the cloud. By answering a few foundational questions, you can learn how well your architecture aligns with the cloud best practices, and you can also gain guidance for making improvements. For this, you can read more about it on this website, and also on your AWS console, you can check out the well-architected tool where you will just have to give a little details about your workload, what kind of it is, and then it will ask you a certain set of questions. Around 50-60 questions will be there. You will have to answer them, and then it will evaluate if you are following the best practices or not according to the well-architected framework. And if you are not following, it will give you an action plan also, that this way you can improve it. Okay, so that's how you can be working in the best possible way on the cloud, and especially with the AWS core services. So these were just a few best practices. There will be many more, but in this video we have just focused on the basic ones. So make sure to work by following the best practices, and I hope you have understood all of them. We'll meet in the next video with a new topic. Thank you.